Hello, this presentation is on unit circle and periodic functions. A unit circle is a circle whose center is at the origin and has a radius of 1 unit. So a unit circle is a circle whose center is at the origin and a radius of 1 unit. On this figure over here, this is an example of a unit circle. Here's a circle. Center is at the origin and radius of the circle is 1 unit. Now, because the radius is 1 unit and the center is at the origin, then the point of intersection of or between point of intersection of the circle and the x-axis would have an x coordinate 1 and a y coordinate 0, and a point of intersection of the circle and the y-axis, x coordinate 0, y coordinate 1, and so on. And this point of intersection will be a negative 1, 0. This point of intersection will be 0 and negative 1. Now, what is periodic function? So what is a periodic function? So periodic function is a function that repeats its values in regular intervals or periods. And we're going to be looking at check functions, of course, and all check functions actually repeat their values. So we're going to be going back and looking at the six check functions, but this time on a unit circle. So here's the unit circle on the figure. As you see, the center is at the origin. The radius is 1. Now, this side of the right triangle is the adjacent, so it's x, and this is the opposite to this angle, which is y, and this is angle theta. So if the terminal side of an angle theta is in standard position, as you see, the terminal side over here is the hypotenuse, as you see, opposite to 90 degrees. And the initial side is on the positive x-axis, therefore the angle theta is in standard position. And then if it intersects the unit circle at some point P with x coordinate x and y coordinate y, as you see over here, then we can write the sine of theta as the opposite, which is y, over the hypotenuse, which is 1. And y over 1 is simply y. And then the cosine would be the adjacent over 1, or the hypotenuse, which is 1. So it would be x over 1, which is simply x. So what we can conclude from these two statements over here, because y equals sine of theta, that means the y coordinate of any point on the circle would be the sine of theta, because each time you try to find the sine of an angle theta on this unit circle, it will be the ratio of the opposite, which is the y, divided by 1. And dividing anything by 1 remain as is. So therefore, the sine of theta equals y. It means this is an identity. So any y coordinate would be the value of sine of theta. Same thing in regards to the cosine. So cosine theta equals x, because again, x over 1 is simply x. So cosine theta equals x. That means the x coordinate of any point in the circle would be the cosine of theta. But there's another thing. Now, since x is on the x-axis, all the values of x are found on the x-axis. That means the x-axis is also the cosine axis. So the x-axis is the cosine axis. And the y-axis is the sine axis. It's the same idea, because y equals sine, then all the values of the y-axis actually are the sine values. So it means the y-axis is simply the sine axis, and the same for the cosine. Now, tangent is a ratio of the opposite over the adjacent, which is y over x. It means the tangent of the angle theta of any point on the unit circle, it will be the ratio of y over x. So you take the value of y divided by the value of x. And then every other, and the other three functions will be just reciprocal. So in terms of cosecant, reciprocal of sine, which means 1 over y. The secant is reciprocal of cosine, which means 1 over x. And the cotangent is reciprocal of tangent, which is x over y. Example, the question says the terminal side of an angle theta intersects the unit circle. So it means the hypotenuse is 1 at this point. So sketching a figure is optional, but let's just have a better idea what we are talking about. So the terminal side of an angle theta intersects the unit circle at 1/2 root 3 over 2. So 1/2 would be 0.5 approximately. I mean, it is 0.5 approximately here. And root 3 over 2, root 3 over 2 is somewhere, probably somewhere there. So approximately will be this point over here. So 1/2 comma root 3 over 2. This is the terminal side. This is angle theta. So the question says find the cosine of theta. Well, the cosine we said is the x coordinate of any point on the unit circle. So in this case would be 1/2. So cosine of theta is 1/2. And the sine we said is the y coordinate, which is root 3 over 2. Another example, the terminal side. So the terminal side of an angle theta intersects the unit circle at this point. Maybe at this, we don't have to make another figure. We know that the tangent is y over x. So this is x, also it is cosine of the angle theta. This one is the y, it is also the sine of angle theta. So tangent is y over x, which means negative 3 over 4 divided by root 7 over 4, which is negative 3 over 4 times 4 over root 7. After you simplify, it will be negative 3 over root 7, because you cross out the 4s, the 4 with the 4, and then you rationalize, so it's negative 3 root 7 over 7. Now with regards to cotangent, cotangent is opposite of tangent. So cotangent is opposite of tangent. If it was tangent, it will be y over x. Cotangent will be x over y. So root 7 over 4 divided by negative 3 over 4. And then you multiply by the reciprocal, so root 7 over 4 times negative 4 over 3. So the 4 and the 4 crosses out. So we are left with negative root 7 over 3. Secant of theta. Secant is the reciprocal of cosine. Cosine is root 7 over 4, so it's 4 over root 7. You rationalize 4 root 7 over 7. And then cosecant, which is a reciprocal of cosecant reciprocal of sine. Sine is negative 3 over 4, so negative 4 over 3 is the cosecant. So negative 4 over 3 will be the cosecant. Special angles and their values on unit circle. We want to go ahead and fill in all uh, um, this information, but I'm going to explain how how all this information correlate to each other. Okay, so let's minimize. Okay, so we're going to start with the degree measure of those special angles. So this is a unit circle, of course, again, whose radius is 1 unit. So let's start with the degree measure. So if we start with the um, the first angle whose terminal side is on the x-axis and it is in standard position. So it means the initial side is on the positive x-axis and the terminal side is on the positive x-axis. So the angle must be 0 degrees, because the terminal side is overlapping with the initial side. Now, this angle here, if we add 90 degrees, that's a right angle. So this would be 90 degrees. Now, if we divide 90 by 3, we got 30. So it means 90 divided by 3 is 30. So it means the measure of this angle here is 30 degrees. This one here is 30 degrees. The angle, the measure of this angle here is actually 60, because this is 30 plus another 30, so that's 60. And then if we keep on going, plus another 30, that's 90. 90 plus another 30, that's 120, so this is 120. 120 plus another 30, that's 150. 150 plus 30, that's 180. 180 plus 30 is 210. 210 plus 30, that's 240. 240 plus 30, that's 270. 270 plus 30, 300. 300 plus 30, 330. 330 plus 30, 360. So we're able to label all the multiple of 30 degrees angles by just simply adding 30 degrees to each angle. Okay. Um, let's okay. Let's delete this. So now we notice there are other angles that have not been labeled yet. So if you look at, again, this is 0, and that's 90. So if you divide 90 by 2, that's 45. And this angle over here is right in the middle. Right in the middle. So this would be 45 degrees. So 45 degrees plus 45, that's 90. We already have 90. 90 plus 45, that's 135. And then 135 plus 45, that's 180. 180 plus 45 is 225. 225 plus 45 is 270. 270 plus 45, that's 315. 315 plus 45 is 360. So in regards to the measure of the angles in degrees, we have all of them. These are the special angles on the unit circle. Now the equivalent angle in radians. So the 0 degrees angle, 0 degrees angle is equivalent to 0 radian. The 30 degrees is equivalent to pi over 6. Pi over 6. Maybe I'm going to use this line as a division line. Let me just use this as division line. Let's go back. So that's pi over 6. And now let's take care of the multiples of pi over 6, means the multiples of 30 degrees. And then we do the multiples of pi over 4, which are the multiples of 45 degrees. So that's 1 pi over 6. This is 2 pi over 6. 2 pi over 6 simplifies to pi over 3. And then if this is 3 pi over 6, which simplifies to pi over 2. So let's do the counting again. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 4 pi over 6, that's 2 pi over 3. When you simplify, 2 pi over 3. And so 4 pi over 6, 5 pi over 6, 5 pi over 6. You can simplify it. And then 6 pi over 6, which simplifies to simply pi. And then 7 pi over 6. You can't really simplify this. 8 pi over 6. 8 pi over 6 is 4 pi over 3. And then this is, so 6, are we counting correctly? No, 7, 8 pi over 6. 9 pi over 6. 9 pi over 6 is 3 pi over 2. So that's 3 pi over 2. And then 10 pi over 6. 10 pi over 6. 5 pi over 3. 10 pi over 6. 11 pi over 6. Stays as is. 11 pi over 6. So we got all the radian measure of angles that are multiples of pi over 6. Now the next one is easier, which is the 45 degrees. So 45 degrees in radians is equivalent to pi over 4. So let's use different colors to okay. Let's take this one. So pi over 4. So 1 pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, so 3 pi over 4, and then 4 pi over 4, which is pi, and then 5 pi over 4, 5 pi over 4, and then 6 pi over 4, which simplifies to 3 pi over 2, and then 7 pi over 4, 7 pi over 4, and then 8 pi over 4, which is 2 pi. 8 pi over 4, which is 2 pi. Now, in regards to the measure in radians, we offer special angles on the unit circle. We have all of them. Now, what's left are those, the XY coordinates of each point on this circle. So let's start with the easy ones. Start with the easy points. Let's do this once. So because this is unit circle, we said the radius is 1, so therefore the x of this point is 1, the y is 0. And this point here, the x is 0, the y is 1. This point here, the x is -1, the y is 0. This point over here is 0, -1. So these are kind of the points on the x-axis and the y-axis. Now let's take care of the other points. I'll start with this one over here. So this is a 30 degrees angle. And if I make a triangle here, this will be 60 degrees. So 30, 60, 90. So 30, 60, 90 triangle. What do we know about 30, 60, 90 triangle? We know that if this is x, that will be 2x. And this will be root 3x. So because the radius of the circle is 1, it means the hypotenuse of this triangle is 1. So it means 2x here equals 1. So we do 2x equals 1. It means x is 1/2. X is 1/2. X is 1/2. It means this opposite side, which is x, is 1/2. And here, here is 1. We know that this hypotenuse over here is 1. And we know x is 1/2. So therefore, this side over here adjacent is root 3 times 1/2, which is root 3 over 2. So this would be 1/2. This would be 1, and that's root 3 over 2. Well, it looks like the 1/2 over here is the y-coordinate. So 1/2, that's the y-coordinate. And the root 3 over 2 is the x. So root 3 over 2 is the x. So that's how we get the coordinates of the first point. I'm going to erase this because otherwise if I draw another triangle, it would be very messy. So I'm going to remove this. Got to be careful not to take anything else. Okay, I'm going to erase this too. So let's do the second point. The second point, let's use this second point. We know that this is 45. And if I make my triangle, this would be 90. So that's 45. So it's a 45, 45, 90. So what do we know about 45, 45, 90 triangle? If this is 45, this is 45, that's 90. So this is x, this must be x. This will be root 2 times x. Now, I know that the hypotenuse over here is 1. So it means root 2 times x equals 1. So x equals 1 over root 2. After you rationalize, is root 2 over 2. So if x is root 2 over 2, it means this x is root 2 over 2, and this x is root 2 over 2. So it means this side is root 2 over 2, and this side is root 2 over 2. So it means the x coordinate is root 2 over 2, and the y coordinate is root 2 over 2. Okay, I'm going to delete again. So so far we got 2 points. Now the third point is same idea. I'm just going to explain it quickly. So the third point actually, this angle is 60. So if I make a triangle like this is going to be 30, and that's going to be 90. So what happens is when I find the values of x and y, the x will be 1/2, and the y will be root 3 over 2. So they kind of switch. If you notice, the first point is root 3 over 2, 1/2. This is 1/2 root 3 over 2, because it's the same triangle, but just the sides have exchanged. So this was the adjacent here was the opposite. I mean, the opposite here, not still opposite. Just this, the length of the sides different. So the opposite 30 degrees um, became the adjacent. On the other triangle, the opposite to 30 degrees was the opposite, not the adjacent. So now, in regards to the remaining points around this circle, we don't really need to do much work. We can just get those values from the first quadrant values. So let's start with this point. Let me use different color. This point here has x coordinate 3 over 2 and y coordinate 1/2. Well, this point, if I draw a straight line, realize that it is on the same horizontal line as this point over here. So it means the y coordinate must be the same. So if the y coordinate is 1/2, the y coordinate here must be also 1/2. They have the same y coordinate. The x coordinate, they're just opposites. This is root 3 over 2 because this one is on the negative side, so negative root 3 over 2. Negative root 3 over 2. So it means the absolute value of these points the same, but they have opposite signs. Just the x in this case. Same for this point and this point. So the x becomes negative root 2 over 2, and the y is root 2 over 2 because the y is still positive. And then this point over here is negative 1/2, and then root 3 over 2. Root 3 over 2. Root 3 over 2. Okay. And then same for this point here and this point over here. We know that the x and the y of this point here are negative. Both are negative. So it means, oh, but I don't have the values over here. I need to, okay. So let's do different, let's do vertical line. Let's do vertical line. So let's compare this point with this point. So this one with this one. So they have the same x coordinate, which is root 3 over 2. And the y coordinate, this is 1/2, and this will be negative 1/2. And then this point and this point, the x coordinate is root 2 over 2, same thing, root 2 over 2. And the y coordinate is negative root 2 over 2. And this point here, the x coordinate is 1/2, and the y coordinate will be negative root 3 over 2. Okay, that something. Fix that. Pi. Okay, and let's take care of these points over here. So this point here and this point here, in regards to the absolute value of the x and the y, they have the same values but opposite signs. So both x and y here are negative. So negative root 3, very small. So negative root 3 over 2, negative 1/2. And this one is negative root 2 over 2. negative root 2 over 2. This one is negative 1/2, negative root 3 over 2. I just get them close from this point over here. Right. And with this, we have all the values and we have all the angle measures in radians and degrees. All right, now we can go ahead and work on some examples. Find the exact value of each of the following. So we're going to be using the unit circle to find the values of each of the following. So first, example A will be sine of 135. So let's go back to the unit circle. Sine of 135. So this is 135 over here. The sine will be the y coordinate. So root 2 over 2. Root 2 over 2, because the sine is y coordinate. So first one here would be root 2 over 2. And then the next one, example B, cosine 7 pi over 3. Cosine 7 pi over 3. 7 pi over 3, which is, sorry. Yeah, let's just count 7 pi over 3. Okay, so let's count. So 1 pi over 3, this is 1 pi over 3 over here. 2 pi over 3, 2 pi over 3. 3 pi over 3. You need to count multiples of pi over 3. 4 pi over 3. 5 pi over 3. 6 pi over 3. 7 pi over 3. So 7 pi over 3, we're looking for the cosine, which would be 1/2. So 1/2. Cosine 7 pi over 3, which is 1/2. Okay, tangent 5 pi over 6. Tangent 5 pi over 6. 5 pi over 6. So we got 1 pi over 6, 2, 3, 4, 5 pi over 6. So tangent is y over x, so 1/2 divided by negative root 3 over 2. So 1/2 divided by negative root 3 over 2. So 1/2 divided by negative root 3 over 2, which is 1/2 times 2 over negative root 3. So you simplify, it's negative 1 over root 3. You rationalize is negative root 3 over 3. Okay. Example D, cotangent 5 pi over 3. Cotangent 5 pi over 3. So 1 pi over 3, 2, 3, 4, 5 pi over 3 is over here. 5 pi over 3. Cotangent is x over y, so 1/2 divided by negative root 3 over 2. So 1/2 divided by negative root 3 over 2. So 1/2 over negative root 3 over 2. You multiply by reciprocal, so 1/2 times negative 2 over root 3, which is going to be negative 1 over root 3. You rationalize negative root 3 over 3. Bit messy. Secant of 120. Secant is a reciprocal of cosine, so we need to find a cosine of 120. 120 is over here. Cosine will be the x coordinate. Reciprocal of it, and the cosine coordinate, the x coordinate, or the cosine coordinate. It's negative 1/2. The reciprocal of that will be a negative 2 over 1, which is negative 2. So this simply would be negative 2. Negative 2. Cosecant of negative 3 pi over 4. Cosecant of negative 3 pi over 4. Cosecant is a reciprocal of sine. So we need to find sine of 3 pi over 4. So sine of 3 pi over 4 is here in the second quadrant, 3 pi over 4. reciprocal of sine, so it's 2 over root 2, because the sine is root 2 over 2, so cosecant is 2 over root 2. So 2 over root 2, so 2, oh, sorry, made a mistake. This is a negative angle, cosecant of negative 3 pi over 4. Let's go back, negative 3 pi over 4. So we need to actually, the angles are clockwise, the direction of the angles. So 3, sorry, 3 pi over 4, negative 3 pi over 4. So 1 pi over 4 over here, 2 pi over 4, 3 pi over 4. So negative 3 pi over 4 is over here in the third quadrant. So we said we take the cosecant, which is a reciprocal of sine. So the sine here is negative root 2 over 2. We take the reciprocal, which is negative 2 over root 2. So negative 2 over root 2. So negative 2 over root 2. So negative 2 over root 2. And then we rationalize and simplify. So it will be negative 2 root 2 over 2, which is negative root 2. Tangent of 0. Tangent is sine over cosine, which is y over x. Tangent is y over x, so tangent 0. Here's a 0 angle. So the y is 0, the x is 1, so 0 over 1, which is 0. So the tangent is 0 over 1, which is 0. Tangent of pi over 2. If you look at the unit circle, pi over 2, the x is 0, the y is 1. So 1 over 0, which is undefined. So tangent pi over 2 is undefined. Cosine 3 pi over 2. So let me just go back to unit circle. 3 pi over 2. So 3 pi over 2 over here, all the way on the bottom, 3 pi over 2. We want, I think, the cosine, which should be 0. Yeah, cosine 3 pi over 2. So the x coordinate, which is 0. Cosine 3 pi over 2 is 0. Sine 3 pi over 2, if you look at the sine at the 3 pi over 2, the y coordinate is negative 1, so you put negative 1. Secant pi over 2, well, secant is a reciprocal of cosine. Cosine pi over 2 is 0. The reciprocal of 0 is undefined. So we can say it's undefined because the reciprocal of 0 is undefined. Cosecant of 0. Cosecant is the reciprocal of sine. Sine of 0 is 0. Reciprocal of 0 is undefined. Actually, we can show some work. 1 over sine of 0. And sine of 0 is 0, so it's undefined. Okay, undefined. We can do the same thing with this one here instead of just giving the answer straightforward. We know that the secant is 1 over cosine of pi over 2. And cosine pi over 2 is 0, so that's again undefined. Okay. All right, so now we are going to be looking at the periodic functions. We said a periodic function is a function that repeats its values in irregular intervals of periods. So now we're going to determine each trigonometric function, each trigonometric function's period. What is what interval it takes for the value of the function to repeat. So let's start with the sine function. Sine function. So sine function actually, it takes 2 pi for its value to repeat. So it means sine of theta plus 2 pi means adding 2 pi is simply the same as sine of theta. Well, let me show you how that works. So if we draw a circle, and let's say we take 30 degrees angle theta. which is, or let's just go back to the unit circle. Maybe that's easier. Okay, so the sine of 30 degrees is 1/2. So we're talking about the sine. Now the 1/2 repeats again over here, the sine, the y coordinate. However, the angle from this terminal to this terminal is not equal to the angle from this terminal to that, meaning this angle, after we add the same angle, we're not going to get back, we're not going to get back the same value. So this angle cannot be the period, because each time you add that period, you should get back the same value. So the 1/2 is here and there. Over here, it's negative 1/2, and over here is negative 1/2, which is not the same as positive 1/2. So um, this angle here cannot be the period, because if it is, if we add the same angle, the yellow one, is not congruent to the blue one, blue angle. But the periodic functions, the concept is each time you add the same interval or the same angle, you should get back the same value, which doesn't happen in here. So it means the only way to get the period of sine is we need to add an angle that each time if we add the same angle, we get back the same value. So if we add 360, we get back 1/2. We add another 360, we get 1/2. Another 360, 1/2. So either 360 or 2 pi. So the period of sine is 2 pi or 360. So it means um, the sine of theta plus 2 pi is the same as sine of theta, because the 2 pi will just take you back to the same point. Same idea with cosine. I don't need to go over it. It's the same idea. Secant is a reciprocal of cosine, so it has the same period, and the cosecant is a reciprocal of sine, which has the same period. Now, in regards to tangent, actually the values of tangent repeat after pi. The tangent repeats after pi, and the cotangent is a reciprocal of tangent, so the same thing. So why the tangent repeats after pi? Well, let's look at the unit circle. Pi, which is 180 degrees. Pi is equivalent to 180 degrees. So let's take a look over here. So let's say tangent of pi over 4. This is pi over 4. Okay, tangent of pi over 4. Which is root 2 over 2 divided by root 2 over 2, which is 1. Tangent pi over 4 is 1, because it's y over x, it's 1. If I add 180 degrees, it will be this one over here, 180 degrees. What we notice is tangent is negative root 2 over 2 divided by negative root 2 over 2. So negative root 2 over 2 divided by negative root 2 over 2, which is 1 again. So if I add another pi or 180 degrees, again, I'm going to have root 2 over 2 divided by root 2 over 2, which is 1 again. So each time I add the pi, I'm going to get a 1. The value of the tangent is 1. I add the pi is 1, or 180 degrees, 180 degrees. That's why the period for tangent is pi or 180 degrees. So, meaning that if we add a pi to some angle, theta, then the tangent of theta plus pi is the same as tangent of theta. Same, no difference. Same with the cotangent, because that's a reciprocal of tangent. Work on example 5. What does example 5 say? Example 5 says, find the value of each trigonometric function. Sine of pi over 3 plus 4 pi. Well, the sine period is 2 pi. So this is pi over 3. And if you add 2 pi and add 2 pi again, It's like you're going back to the same point. So here's is the pi over 3 is somewhere here. If you add 2 pi, you go back to this point. You add another 2 pi, you go back to the same point. So it means sine of pi over 3 plus 4 pi is the same actually as sine pi over 3. And sine pi over 3 is root 3 over 2. You can get that on the unit circle. Let's do the tangent. Tangent, we said its period is pi. So tangent pi over 4 is somewhere here. So if you add pi, it will be this point here, which would be, so tangent pi over 4 is 1. Tangent of 1, 2, 3, 4, 5. After you add a pi, the tangent would be 1 again. After you add another pi, 1 again. You add another pi, 1 again. So it means tangent of pi over 4 plus 3 pi is the same as tangent of pi over 4, which is 1. The third one, secant, which is a reciprocal of secant, which is a reciprocal of cosine. So whether you add a 2 pi or subtract will be the same thing. So now this is the same as secant. The period for secant is 2 pi. So 3 pi over 2 minus 2 pi minus pi. Because 3 pi is simply is addition of 2 pi and pi. So when you subtract 2 pi, so when you subtract 2 pi, you pretty much go back to the same point. It means this is equivalent to secant of 3 pi over 2 minus pi. Because subtracting this 2 pi doesn't change anything. It just takes you back to the same value. So now we have secant of 3 pi over 2 minus pi. We can find the common denominator. So secant of 3 pi over 2 minus pi, that's pi over 2. And what's a secant of pi over 2? Secant is the reciprocal of cosine. So it's 1 over cosine pi over 2. Cosine pi over 2 is 0. So this is undefined. It turned out to be undefined. Last one, which is example D, says simplify. We may not end up with a value, so we just need to simplify. So we have cosine of theta plus 4 pi. Because the period for cosine is 2 pi, it means adding 2 pi and adding another 2 pi. That doesn't change anything in terms of value of cosine of theta. Doesn't change anything. So this is same as cosine of theta. The first one is same as cosine of theta. Minus 2. Now if you do cosine of theta minus 2 pi, same thing. So if you subtract 2 pi, you go back to the same point. So it means this is equivalent to cosine of theta. What I meant is cosine of theta minus 2 pi is equivalent to cosine of theta. Now cosine theta minus 2 cosine theta is negative cosine of theta. And we, of course, we don't know what theta is. Theta is any angle on the unit circle. So we couldn't know what the value is in this case. We just simplify. This is the end of the presentation. Thank you for watching.